Alright. So, hi everyone. I want to start off by talking about a scary math problem. Scary math problem. 3x plus 4 equals 25. This is probably a kind of problem that you've seen hundreds or thousands of times over the course of your 13-ish years of education. You maybe first saw it in Algebra 1 or pre-algebra, and then you've probably seen it in a more applied setting or as part of a problem as you got to higher math classes. Now, how do you solve a problem like this? There's a pretty straightforward approach. You can subtract 4 from both sides, you get 3x equals 21. Divide both sides by 3, you get x equals 7. And you're done. So, the kind of problem that this is, doesn't really ask you to, figure out how to solve it in a sense. You can basically know you can solve it in a process like we just described. And then you can solve 100 or 1,000 problems that are similar to it, just maybe different numbers. Maybe instead of a 4, there's a 7. Maybe instead of a 25, there's a 28. And you can solve a vast array of similar problems. That makes this kind of question really easy to teach, and it also makes it really easy to test. So I'm going to step back for a minute and talk about my project as a whole, and then we'll return. So my project is on reforming the grade school math curriculum to emphasize more on critical thinking and real problem-solving skills as opposed to sort of systematic applications of solutions. So to do that, I'm going to talk about 3 things. First, I want to talk about so-called what happens in critical thinking. We think of math as a subject that's difficult and requires you to critically think when you're solving problems throughout your education, but I want to talk a little bit about that and see if that's the case. I then want to talk about the new math era, which was a period of education reform in the 1960s. And it was a failed education reform attempt, and I want to look at that and see why it failed and how we can improve upon it for my new math proposal, which is what I hope will be a reform solution that will be successful. So, what happens to critical thinking? We were talking about this problem earlier, and it seems like a very specific problem that is suited to Algebra 1. But if you look at the kind of classes that most students take, you're progressing from one kind of math to another. Not all students get to the end, obviously, but these are sort of the core classes that students take in grade school. And a lot of the classes are focused on very similar kinds of problems to the algebra problem that we already discussed. There's a lot of focus on computation. You're given a problem, you have to solve it, and then you're given a similar problem, solve it the same way. Maybe you're given another problem, and then you go to a test, and then you solve something with just different numbers. It's a lot based on the kind of idea where you plug numbers into a formula, and out pops the answer. There's not much creativity. There are some exceptions in this curriculum, but for the most part, the idea is really that you're learning how to solve problems, and you're able to then solve the problems in the future. So we do say that that part of the difficulty in math comes from having to think in difficult ways about problems. But this is really just one side of math. This is what I call computational math. And this is the sort of traditional curriculum that we have seen in the past. The new math era changed all of this. The new math era was a period in the 1960s. It was sort of at the height of Cold War and the space race. And when the Soviets finally got Sputnik 1, the first artificial satellite, into space, a lot of leaders in education in the United States thought, well, maybe we're behind for some reason. Maybe our mathematicians, our scientists, our engineers aren't as competent as the Soviets. So they thought, let's try and radically change what we're teaching in our schools and see if that can fix the problem. So they switched from our traditional curriculum of algebra and so on to abstract math ideas that you might see in higher level math classes, such as at universities. Topics like set theory, number bases, which is maybe a little bit more simple than that, abstract algebra, and more generally, axioms and proofs. And the idea was that higher level math is thought to be very much focused on intuition and sort of clever constructions of solutions. And if we ask students to start doing that from day one, then they'll be better prepared and more competent thinkers by the time they reach university. So this is sort of the idea, the construct of the new math era. There was a prominent thinker, or professor at the time, Professor Morris Klein. As you can tell by his distinguished figure, he was a professor of mathematics, and he taught at New York University. And he wrote a book called Why Johnny Can't Add. The Failure of New Math. And the book talked about a lot of the big problems with both the traditional curriculum and with the new math curriculum. So the traditional curriculum issues that are similar to ones that I've already discussed. There's lots of emphasis on sort of rote application of the same kinds of solutions, and not much room for critical thinking. If we then look at the new math era curriculum, what were the problems with that? So one of the basic problems is that students didn't understand the material. They didn't understand the material because they were launching right in to abstract math without ever getting a foundation for how math actually, for sort of like the basic computational math skills. So a student would be able to tell you that 5 times 7 equals 7 times 5 by the commutative property, but maybe they wouldn't be able to tell you that that's equal to 35, or maybe they'd have to struggle to remember that. And that's a big problem because one of the most direct uses of math are that it's just useful in everyday life. If you want to calculate your tip, if you want to calculate taxes, if you want to split a bill. So students across the board that were part of this new math curriculum weren't gaining those basic skills. Furthermore, they were supposed to be learning these skills in school, but the teachers that were teaching them were not brought up learning these same new math curriculum. So the teachers were unequipped to teach them the ideas that they were supposed to be learning. So students were asked to learn these abstract ideas, but were given no resources to actually learn them. So why Johnny can't add? He can't add because they skipped over the basic math computation skills and launched right into the abstract ideas that the students weren't prepared for. So with that in mind, my goal is to create a proposal that can take some of the good aspects of new math and apply them in a modern setting to a new proposal for reform. So if we return to look at the traditional curriculum, I think that this is, in general, is a curriculum that we should keep. It teaches a lot of the basic skills that are just useful for all people, not just mathematicians or scientists. And it's very structured in that it goes like sort of step by step towards more complex ideas. But in my mind, there are really multiple kinds of students that are going through this curriculum. There's one class of students that are ranging from struggling with this curriculum to just getting by. And then there's another class of students that are getting through this pretty easily without much struggle. Maybe they have some sort of natural aptitude for mathematics. And the thing is, for the students that are advanced at math, they basically just progress through this list of classes quickly. So they go from one kind of computational math to another, and they never really get a chance to pause and think about the more interesting ideas of what they're learning. At each step of the way, there's always the opportunity to step to the side and think about what is going on behind the scenes. So when you learn about the problem like 3x plus 4 equals 25, you might be able to think about what is x? Are there multiple solutions for x? What is the number 25? It's 2 10s and 1 5. Maybe we could represent that differently. There's a lot of different questions we can ask that sort of get glossed over in the traditional curriculum. So for students that are good at it, for students that are good at this kind of computation, rather than rushing them through the normal curriculum, we should give them a chance to explore some higher level ideas in parallel to the normal curriculum. But we run into the same problem that the new math era ran into. Who's going to teach these ideas? If they're abstract ideas that are more advanced than students typically learn, a lot of teachers were not required to learn them in order to get their credentials. So how are we going to actually solve this problem that the new math era had? The key is that we have a technology available to us that was not available in the 60s. That is this. Does anybody know what this represents? Yeah, the internet. This is a phenomenal new technology that can be used to spread information really quickly. And there's this new phenomenon of online learning, where educators can create a video explaining some concept, upload it, and then across the world, millions of students have access to it. So we can use online learning to create a system of videos geared towards advanced grade school students and teach them about abstract concepts. And in this fashion, we can step our education away from the kind of least common denominator education that we currently have, and move towards a system where students can receive education and be pushed at their appropriate level. So that's my proposal. Thank you for listening.